Hey guys, Mrs. Flanagan here. Today we are going to talk about sketching parabolas from vertex form. This is vertex form. Go ahead and take a minute to write that down. This is different than what we've done previously in 5.2 and 5.3. We were working with standard form, which looked like this. So vertex form, notice, has parentheses. And the nice thing about vertex form is we can figure out what the vertex is just by looking at the equation. Remember, the vertex is either the lowest point on the parabola, in this case it would be a minimum, or the vertex is the highest point on the parabola, which in this case it would be the maximum. When looking here at your vertex form, you can identify the vertex by looking at the h and the k. The h is the number that comes after x. And notice that this h has a subtract sign right before it. What that means is that the h, which is the x value of our vertex, actually has to be the opposite sign of the number that follows x. And we'll do examples so this will make more sense. The k is here, and that's the y value of our vertex. And because that's a plus k, it's going to stay the same sign. So we don't have to do anything special with that. So h is the x value of our vertex, and k is the y value of our vertex. And the axis of symmetry then is x equals h, right? It's the x value of our vertex. Remember, you have to put x equals. X equals has to be there. If it's not, it is wrong. And then if the a, so the number in front of our parentheses, is positive, it opens up. If a is negative, it opens down. To figure out the y-intercept, remember that's when x equals 0. So we will replace all of the x's with 0 and solve for y. In this case, there's just one x, so we'll just replace this x with a 0 and solve for y. Basically, it ends up just typing into your calculator. And then the point symmetrical to the y-intercept, for the x value, it's the same distance from the vertex as the y-intercept. So it's on the other side of the vertex. For the y value, it's the same y value as the y-intercept. And we'll do examples where this will make more sense. So with our first example, the equation is y equals x minus 3 squared plus 2. So remember, our vertex is the hk. The h is here, and we do the opposite sign. So because this says -3, we do the opposite of negative and make it a +3. So this is a +3. And then the k is this 2. And it's a +2, and we don't need to change anything with that, and so we keep it as 2. The axis of symmetry is x equals the 3. Again, you have to put the x equals. If you don't put x equals, it is wrong. And then the direction of opening, there is no number written. When that happens, the number is actually a 1, right? And that is a +1. So because A is positive, then it's going to open up. So it'll look like the U for up. And then the y-intercept, we replace the x with 0. So we have y equals, replace this x with 0, and -3 squared plus 2. So again, this x I'm just replacing with the 0. The x and the 0. Just replace that. And now you can type this part into your calculator. So type in your calculator, and it ends up giving us y equals 11. And so you need to write the y-intercept as 0, comma 11. If you don't write it as an ordered pair, it is wrong. Go ahead and try part B on your own, then come back to check your answer. If you end up getting it wrong, make sure you fix your answer so that it's correct. Go ahead and pause the video now. These are your answers. Make sure you update your answers if you got any of them wrong. For example C, notice that we don't have any parentheses. So what that means is there's actually the number 0 inside of parentheses with our x. So the mathematical equivalent equation is the x plus 0 being inside of the parentheses, right? Because x plus 0 is just x, and it's still being squared. So this is the same thing. It might be easier to visualize the fact that the x value of our vertex is a 0. So the x value of our vertex is a 0. Technically, we do opposite sign, and so it would be a -0, but we don't write -0. We just keep it as 0. So the vertex is 0 for the x value, and then the y value is -3. The axis of symmetry, you have to put the x equals, and it ends up being the same number as the x value of our vertex. The direction of opening, here is our A, so that is a -1, which means A is negative. And since A is negative, we know that it opens down. And then the y-intercept, we replace the x that we see here with a 0. So it's a negative. And then we have a 0 that's being squared. Subtract 3. Type this into your calculator, or if you can do it in your head, either way is fine. But after we type it into our calculator, we get y is equal to -3, and so the y-intercept is 0, -3. It ends up being the same as our vertex. The vertex and the y-intercept are the same point. Go ahead and try example D on your own. Pause the video and then come back to check your answer. Go ahead and pause the video now. And here are the answers. Remember to update your answers if you ended up getting anything wrong. For our next examples, we are now actually going to sketch the graph. And remember that it needs to be U-shaped, and we need to have 3 coordinate points on our graph. And this form right here has no parentheses. So again, that's like having a 0 inside of the parentheses. And then there's no plus or minus at the end. And so that's like having a +0. So in this instance, the H is a 0. And the K is also a 0. And so when we plot the vertex, it's 0, 0. Right here is the vertex 0, 0. And then the y-intercept, because it's when x equals 0, notice that we already found this. We already found, because the vertex is when x equals 0. So that just happens to be the exact same as the vertex. And if that's the case, you don't have to do any work. It's the exact same as the vertex. And then the point symmetrical to the y-intercept, because the vertex and the y-intercept are the exact same, there's not going to be a point symmetrical to the y-intercept. So you would say that there's none. which means we need other points. Right now, we only have 1 point. We have to have 3 points. So we need to find 2 more points. The easiest way to do that is to plug in x values that are closest to the x value of your vertex. Well, to the right of the vertex, the closest x value is a 1. So we are going to take our original equation, which was y equals x squared, and we are going to plug in x equals 1. We take our y equals, plugging in the 1 into our x, and that's squared. So 1 squared is 1, which means we have the point 1, 1. Now let's pick another x value. So let's plot our point 1, 1 right here. And let's go on the other side of the vertex because again, I want to pick x values that are as close to the vertex as I can get. And 1 and -1 are the closest x values to our vertex. So let's plug in an x value of -1. So plug in x equals -1, which means we have y equals, remember, we're taking x and then squaring it. So whenever I'm plugging into x, I need to use the parentheses. So -1 and then squaring it, that is equal to 1. -1 squared is 1. So we have the point -1, 1. And let's plot that point, -1, 1. And now that we have 3 points, we can create our graph. It needs to be U-shaped, right? This is U-shaped. It cannot be V-shaped, right? If you go like this, looks like a V. No, that's bad. It's not a V-shaped. It has to be a U-shaped. If you end up putting a V, it will be marked wrong. You need to put a U. All right, for our next example, the x value of our vertex, remember it needs to be the opposite sign, so the opposite of -2 is 2. So the x value of our vertex is a +2. And then notice there's no plus k or minus k. So in that case, it's a +0. So the y value of our vertex is 0, which means our vertex is at the point 2, 0, which is right here. And now we need to find the y-intercept. So the y-intercept is when we take our equation, right? We have the -2 inside the parentheses, and it's being squared. And we are replacing this x with 0. The y-intercept is when x equals 0. So replace x with 0. And when we do that, this gives us y equals 4, which means the y-intercept is 0, 4. So 0, 4 is the y-intercept. And now we want to do the point symmetrical to the y-intercept. Remember, on the first page, we talked about how to find the point symmetrical to the y-intercept. So the x value is the same distance from the vertex as the y-intercept. It's just on the other side of the vertex. So what that means, this is our vertex. So here is our vertex, and here is our y-intercept. It needs to be the same distance, that's left and right distance, since we're talking about x values. X values are left and right from the vertex. So the left and right distance, so from here to here, that's a distance of 2, which means on the other side of our vertex, it also needs to be a distance of 2. So from here to here, that's a distance of 2. And that means our point is here because the y value is the same y value as the y-intercept. So the y value stays the same and the x values are the same distance on either side of the vertex. So the point symmetrical to the y-intercept is an x value of 4 and a y value of 4. So 4, 4. And then because we already have 3 points, we don't need other points, so we can just say this is none, or you can put not applicable, or don't need, and then you graph it. Remember, it has to be a U-shaped, don't do V-shaped. All right, let's skip example C for now and come to example D. So again, this doesn't quite look like vertex form because it doesn't have the parentheses. So let's just add in the parentheses, and it's basically a 0 inside those parentheses, right? This is equivalent to this. Just an easier way to visualize that the x value of our vertex is 0. So the x value, again, of our vertex is 0. And then the y value of our vertex is negative 5. So 0, negative 5 is here. That's our vertex. And the y-intercept, it's always nice when our vertex has an x value of 0 because we know that the y-intercept is when x equals 0. Well, we already found that. This is when x equals 0. It's 0, negative 5. So our y-intercept is 0, negative 5, which is the exact same as our vertex. And when that happens, then there is no point symmetrical to the y-intercept because we can't go on either side of our vertex since the y-intercept and the vertex are the same point. And then the other points, we need 2 other points. So what that means is we're going to use our equation, the y equals, what was it? Negative 3x squared minus 5. And we're going to plug in x values on either side of our vertex that are really close to our vertex. So an x value of 1 is really close to our vertex, and an x value of negative 1 is really close to our vertex. So this is when x equals 1. We have y equals negative 3, and then our x is being squared, and we're subtracting 5, right? So I'm just plugging in 1 in place of that x right there. And then we can type that into our calculator, and we end up getting a negative 8. So one of the other points that we need is an x value of 1 and a y value of negative 8. So 1, negative 8 is here. And then when x equals negative 1, I have y equals negative 3, and then my x is being squared, and we are subtracting 5. So I'm replacing this x with negative 1. Yes, you do need parentheses. If you don't have parentheses when you type this into your calculator, it'll be wrong. So that ends up being a negative 8 as well. So then we have the other point is when x is negative 1, y is negative 8. So negative 1 and negative 8. And then we connect those and make it U-shaped, and we are done. All right, try this example C on your own. Come back to check your answer. Go ahead and pause the video now. Right, here are the answers. Make sure you include both points. You need to actually write the coordinate points and show your work. So you actually need to show the plugging in of 1 and negative 1, and that's what the parabola looks like. For example E, the x value of our vertex, remember it's the opposite sign, so instead of a negative 1, it has to be a positive 1. And then the y value of our vertex, the same sign is what we use, and so that's a 3. So our vertex is 1, 3. And then the y-intercept, remember that's when x equals 0, and we're plugging it into our given equation. So I left a blank for where our x is, and then we're subtracting 1, and we're squaring that, and then adding 3. So plug 0 in for x, and that ends up giving us 4. So the y-intercept is 0, 4. So 0, 4 is the y-intercept. And then the point symmetrical to the y-intercept. So remember, the x value has to be the same distance. This is a distance of 1. And so then on the other side, a distance of 1 ends up being right here. The y value stays the same, and so the point symmetrical to the y-intercept is at an x value of 2 and a y value of 4. And since we have 3 points already, we don't need other points, so you can just say we don't need it, not applicable. And then don't forget to graph it using a U. I want you to now try example F on your own, then come back to check your answer. Go ahead and pause the video now. All right, these are what the answers end up looking like and what our parabola looks like.